Hello friends, welcome to Notebook Videos. I'm happy to delve into the topic of organization of data, wherein you can learn a lot more about how raw data can be handled. We will be answering important questions like how data can be classified into groups for more efficient statistical analysis and uses of the frequency distribution. So, as we try to dig deeper into the topic, let's start with some examples. My friends, here you see USDA 2019 data on the status of India's agricultural exports to USA. According to the FAS agricultural trade system, in the last 10 years, India's export growth in the agricultural sector has grown by 167%. That's clearly an upward rising graph, taking India to the 13th position among US agricultural export markets. Here again, Godrej reports that the agricultural sector accounts for 17% of the Indian GDP. This report is obviously a result of intricate analysis of revenue generated in the agricultural sector and those that have been adding value to the Indian GDP. So, it's very clear that all such analysis would involve large amounts of data, and it's imperative that data needs to be organized to generate such national and international reports. So, what is data organization? It's a process that collects factual material and is required to validate research findings. Such organization is imperative for accurate generation of results and for better analysis. Data can be used to interpret results in various ways, and it's up to the researcher to best handle data to get the right kind of results. Clearly, it's important that analysis and reports require studying of huge amounts of raw data at hand. It's obvious that a collation of large amounts of data would require grouping at the first stage. So for such reasons, we need to look at different kinds of classifications of data. Raw data collected through primary or secondary methods needs to be first organized. Data can be quantitative or qualitative. Quantitative data would contain numerical figures or numbers. Qualitative, on the other hand, refers to attributes or characteristics that we may be grouping the data under. Here we see some good examples of qualitative and quantitative data, and notice that the qualitative data is also referred to as categorical data. Categorical data reflects a particular situation or data that is descriptive in nature. Such data can only be analyzed statistically if we can assign numbers to this data. For example, pass can be designated to be 1 and fail can be designated to be 0, or say eye color can be black, brown or blue, and hence they can be numbered as black is equal to 1, brown is equal to 2, and blue is equal to 3. These are the basic norms by which categorical data can be classified. Such issues do not exist with quantitative data, as we have numbers only. However, quantitative data has its own distinct features. Any quantitative data that contains numbers, like say for example, distance of planets or temperature of coffee or weight figures, are unlikely to be whole numbers. Distances, temperatures, crop yields, heights are rarely reported in discrete numbers. And so numbers can either be discrete or continuous. You heard me right. Data can be continuous. We have learned the concepts of continuity in calculus. For example, distance between 2 points can be continuous data that can be, say, 2.8567894 meters and could be many more decimal places. Here we can round it off to 3 meters for the sake of simplicity. But then, that is nothing but a rough estimation. In fact, in real terms, data is more often continuous than discrete, unless we are talking about examples like standards of class that can only be 1, 2, 3 and alike, or numbers of cars, or number of visits to a tourist place, or number of tickets sold for a movie that can only be represented discretely. These numbers that we are talking about, continuous or discrete, are nothing but observations or units or raw data, and such data may be classified in groups. For example, all numbers between 1 to 1000 or 1001 to 2000, or could be based on time period as well. This is the most common form of grouping data and may result in a frequency table. Frequency tables will be discussed at length in our next lesson. But let's try grouping a set of data ourselves for a start. Let's say you have these 12 numbers: 400, 586, 12, 95, 43, 125, 63, 0, 101, 45, 389, 700, and you wish to group it in sets of less than 100, 101 to 400 and 401 and above. Then we can easily work it out like this. Between 0 to 100 we have 0, 12, 95, 43, 63, and between 101, 400 we have 400, 125, 245, 389, and for 401 and above we have 586, 700. With such grouping of data, you are better informed about where majority of the observations lie. So with this, you may be able to say that observations mostly lie between 101 and 400. Clearly, you have a better understanding of the data now. Here, the classification was based on the range of data. Classification based on time periods is referred to as chronological classification of data. Here, we see a simple tabulation of year and population in crores in India between 1941 to 1991. So here we see the increasing trends in population. Chronological classification of data would therefore comprise of time periods. This is another example of chronological classification, where we see how bicycle models have progressed over time. And this of course depicts time-dependent variations. This is also called time series data. More intricate examples would be annual crop yields, increase in heart diseases over time, changes in school dropouts over time, literacy rates over time, and birth rates across years in the last decade. Next, we move on to spatial classification of data that is dependent upon geographical locations. If data collected is across regions, it is called spatial data. We may need to study the rainfall patterns across all states in India or levels of precipitation at a certain point of time. Some data may be spatially distributed and also time dependent, depending upon periods considered. In relation, here we see the American subcontinent predicting precipitation rates across 4 seasons: winter, spring, summer, and fall. So this data is across time periods and across regions. Your textbook gives examples of the yield of wheat for different countries as an example of spatial data. Clearly, India is one of the leading producers of wheat in kilograms per acre in the world, as given by the table, after USA and China. So, with this, we come to the end of the session of different kinds of data classifications and how raw data is often managed to derive reports and results. In the next session, we shall learn about frequency tables and frequency distribution in detail. I hope you have enjoyed this session, and we look forward to seeing you in our next lesson on organization of data. Thanks.